So, at the top, definition of a sphere is the set of all points in space, equidistant from a given point called the center. Last chapter, in chapter 10, when we were doing area of polygons, we defined a circle being the set of points equidistant from a given point on a plane. So like if I wanted to measure all the points that were, 5 inches from that, then I would measure around and all these points would be so close together that they would make a circle. Same idea with a sphere, but now you're going into space. So now you can bring those points and measure them out in front or out behind. So like if I used my fist as my given point and I measured all the points that were 18 inches from it, I would measure all this way, like a hula hoop. But then since I'm in space, I could measure this way, so I can make another hula hoop that way. We could go at an angle, so then pretty much it'd look like a rubber band ball. Have you ever seen a rubber band ball? Okay, so your sphere, it's the set of all points that are the same distance from a given point called the center. That distance they are away from the center, that's the radius, just like it is in a circle. And the diameter is the segment that passes through the center. Just like in a circle, you got to go through the center to be the diameter. You have a little picture there that you can label. Your center is the little dot. And the diameter is the vertical dashed line. Circumference would be the distance around the sphere or around the ball. If I were to measure like Bree's circumference of her head, if the string was long enough, I would wrap it around and then I would take it off and, make a shape. What shape would her head make? Most likely, thanks. Kind of. How would you find the distance around the circle? 2 pi r, right? It's the same thing with a sphere, because the circumference of a sphere is actually a circle. So it's the same formula, thanks, for your sphere as it is for a circle, 2 pi r. And you'll need to know that for today. Well, you need to know it anyway. You're going to be using that. Cool. You have your two formulas there. The surface area of a sphere is found by taking 4 pi times the radius squared. Surface area, that's the stuff on the outside. That'd be like the peel of the orange or like the leather on a baseball. Volume, the stuff on the inside, is found by taking 4/3 pi r cubed. So what's the only thing you have to know about the spheres to find either surface area or volume? What, Brian? Good, all you have to know is the radius. So down to number 1. It says the circumference of a rubber ball is 13 centimeters. Calculated surface area to the nearest whole number. Surface area of a sphere is 4 pi r squared. So I need to figure out what the radius of this rubber ball is. They tell us that the circumference is 13. You guys just told me, how do you find the circumference of a sphere? 2 pi r. Well, if I substitute 13 in for c, then 13 equals 2 pi r. Can I solve that equation for r, the radius? Yeah, how would I get the r by itself? Just by 2? 2 pi, good. They're going to cancel on the right side. You have whatever's left over. So if you want, this would be the exact radius length, since it's in terms of pi. And you could just take that value and substitute it in for r. So that surface area is 4 pi times 13 over 2 pi squared. The longer you keep it in terms of pi, the more accurate your answer is going to be. If you round right away, then you're going to be off in the end. When I would solve this, I would wait till the very end to use a calculator until I had to. What does it mean to square something? Good. So what's 13 times 13? 169. What's 2 pi times 2 pi? Good, 4 pi squared. So 13 over 2 pi, that quantity squared gives me this. The 4 pi that's out front, that's on the top, technically, when it's a whole number. And then I have a 4 on the bottom, so these 4s are actually going to cancel out. And this pi that's out front, since it's a whole number, that's really in the numerator. And I have 2 pi's down here in the denominator, so I would cancel one of them out. So the exact area, surface area, of the sphere would be 169 over pi. Put that in the calculator and round it to the nearest whole number. That's going to give you the most accurate answer. So if you don't have your calculator out, you're going to want one here in a few minutes. Volume formula, 4 pi r cubed, 4/3 pi r cubed. Diameter is 30, so then your radius is going to be 15. In terms of pi, you just punch everything but the pi value into the calculator. So over here on the graphing ones, if you don't know where your cubed button is, you just do 15 caret 3, or 15 times 15 times 15. You can do it that way too. And then take that times 4/3. So 4 divided by 3. And you should get 4,500 pi then for your answer. Centimeters cubed. The label is going to tell you what you should do with your radius. Volume, centimeters cubed, we cubed the radius. Surface area, centimeters squared, we squared the radius. That's one way you can remember if I'm supposed to cube it or square the radius. Well, think about what you're finding. If it's surface area, area is squared, volume is cubed. Okay, go ahead and do number 3. Find the surface area of the sphere. Surface area is 4 pi r squared. If the diameter is 14, what's our radius then? 7. So then 4 pi times 7 squared, 49, 98, 196. So in terms of pi, that would be 196 pi square inches. What is that to the nearest square inch? 616? You guys agree with them? All right. Not too bad, right? Okay, here come the tricky ones. The volume of a sphere is 1 cubic inch. Find its surface area to the nearest tenth. Remember, volume is the number of cubes that can fit into something. So if I have 1 cubic inch, that's a cube. That's an inch by an inch by an inch. So take one of those little tiny boxes and then shave the corners off, and that's basically the size of our sphere. It's like a marble. Not a marble, excuse me, a bouncy ball. A regular size bouncy ball. They tell us that the volume is 1 cubic inch. We're trying to figure out the surface area. Megan, what do you need in order to find surface area? You need the radius. Do we know what the radius is? Okay, what do they give us? How do you find volume of a sphere? Good. So if the volume is 1, we could replace V and say 1 equals 4/3 pi r cubed. Do you agree? Yes. And I'm going to have to work volume backwards to figure out what the radius is so that I can go and substitute it into surface area. So we got to work backwards to work forwards here. Trying to get r by itself, so I have to move the 4/3 and the pi over to the left side. How are we going to bring 4/3 to the left side? Good, Brian. These are all being multiplied together, 4/3 pi and r cubed. So we would divide it over, but since it's a fraction, dividing by fractions is gross, we're going to multiply by the reciprocal. So we're going to multiply both sides by 3/4. And that cancels out that fraction. 1 times 3/4 is 3/4. So now we have 3/4 equals pi r cubed. My r still isn't by itself. How do I bring that pi over? What? Right, you would divide it, but then I'm dividing a fraction. I don't like doing that. So instead of dividing, I can multiply by its what? What's the reciprocal of pi? Could be, but what's the easiest? 1 over pi, right? Isn't like the reciprocal of 3 we would say is 1/3. So your pi's are going to cancel. Two fractions, when you multiply, you just go straight across. So this is 3 over 4 pi equals r cubed. R is not yet by itself because there's actually 3 r's there. It's r times r times r that equals 3 over 4 pi. So how are we going to get rid of the cubed? Well, to get rid of a square, I would take the square root. So to get rid of a cubed, I'm going to take its what root? Cubed root. It's called a cubed root. And it looks just like a square root, only it's got a little 3 in front of it. To cube something, you take it times itself 3 times. So like, if you want to find the cubed root of 27, that's 3, because 3 times 3 times 3 is 27. Cubed root. All right, on your calculator, so you ready? If you have one like Megan, and I think Taylor, these ones, you have a backwards one, sorry about that. You're going to hit 3 second, and then caret. 3 second caret, and you should have something that looks like that. Your keystrokes are 3 second caret. Did you get that? Yeah, of course. You know, they're in the bottom drawer on my left side. You have to pull the drawer out a ways. It is open parentheses, 3 divided by, you have to do another open parenthesis, 4 pi, then close it twice and hit enter. What did we say again? 0.62? Roughly? Okay, that was our radius. That's what the r is. So now we're going to take 0.62 and substitute it in over here to the surface area. So then you're going to have 4 pi times 0.62 squared. And then it says to round it to the nearest tenth. Is this the 4.831 or something? It is? Okay. Yeah, that would make sense. Never mind. Inches squared. You might still be working. I'm just going to get it started here. 4,200 equals 4/3 pi r cubed. Multiply by the reciprocal. 3/4 of 4,200 is 3,150. Here you can divide by pi because I didn't have a fraction on the left side. That was why I multiplied by the reciprocal on the other one. You should get the same answer. You would still get r cubed equals 3,150 over pi. Then you have to take the cubed root of each side, and you should get a radius of about 10, right? Okay, so now using the radius, you can find the surface area. 4 pi times 10 squared gives us what to the nearest tenth? Feet squared.